Hi guys, welcome to Science Chomp. Today we're going to be looking at significant digits, also known as significant figures. Significant digits are the number of digits in a measurement known with a certain degree of reliability. Now, in an exam, you're going to be asked to figure out the number of significant digits in any given number, and there are 4 distinct rules. So let's quickly have a look at these rules. Rule number 1 is non-zero digits are always significant. Rule number 2, zeros between non-zero digits are significant. Number 3, final zeros after the decimal point are significant. And number 4, zeros used only for the spacing of the decimal point are not significant. Now, what does this all mean? Let's just put this to the side and let's just have a look at some of these examples. Now, I'll put this to the side and I'll talk you through the rules as I do these. So with this one, we've got one non-zero digit and these are zeros. So for this reason, the number of significant figures is 1, or the number of significant digits. The next one, you've got a non-zero, and then in the middle you have a 0. Now, according to these rules, zeros between non-zero digits are significant. So that becomes significant as well. So we have 3 significant digits over here. The next one, 100.0. Now here is actually all of them. So we have 4. Now why is it that we have 4? We've only got one non-zero digit, but we've also got a decimal point and then a final 0, and final zeros after the decimal point are significant. So since you got this and you got the 1 and then the final 0, everything in between also becomes significant. Okay, so that's why it's 4. The next one for D, it's only this one, and for the reason for this, if we go back to this, zeros used only for the spacing of the decimal point are not significant. So all of those not significant. So it's only that 4, because all they're doing is they're spacing it so that the 4 is at the end. The next one, 0.0460, all of that is the zeros before it, they don't count, so we have 3. This one, F, we also have 3, because it's kind of similar to this one. You got final zeros after the decimal point, and it's not 0 point, it's a non-zero point something, which means that's significant as well, so you have 3. Okay. Similarly, if you look at G, this is also going to be 1, 2, 3. This is going to be 4 significant digits. This one, they're all non-zeros, so this is dead easy. 3 significant figures here. Now, these ones are quite interesting. Whenever you see this kind of thing, times 10 to the power of something, this is like adding or moving a decimal point 3 places the other way. So if you imagine it's 4.2000, and then you're moving that decimal point 1, 2, 3, you end up with 4,200. And in this one, I mean, you don't even need to do all of this. That is the number of significant figures. So this one is, I'll write it here, 2 significant digits. All significant figures, same thing. Similarly, this one is just we're going the other way. This would be, imagine you got 2 and you got a whole load of zeros in front. That's still the number 2. And what you're doing is you're moving, it's 10 to the power of minus 4. You're moving this 1, 2, 3, 4. So you end up with 0.0002. And again, you don't even need to do all of that. It's in the answer. It's 1 significant digit. right there. I hope that makes sense. Feel free to replay that. Thank you very much for watching. Goodbye.